Let's go. So we got a busy day today. We've got a lot to fill in. First thing is that we're going to look at is solving equations and solving word puzzles, which tend to be a bit of a challenge, but we'll try and make it as interesting as we can. Once that's over with, then the last part of today is I want to go over your midterm and go through as many details as we can so that you're prepared for it. Okay, so what's the section going to look like? Well, we're going to look at how to solve some difficult questions. I can't think of a better word for it. Complicated questions. So we're going to look at solving equations with weird fractions. We're going to do a thing called calculating rates, and then we're going to do solving word puzzles that have rates in them, stories with rates. Rates are like, it takes John 5 hours to mow the lawn, but his brother can do the same lawn in 2 hours. That's a rate question. And then they finish with, if they both work together, how long would it take them to cut the grass in the lawn? So that's what a rate question would look like. And then we're going to have travel puzzles, and they're going to be word puzzles where people drive here and there, and the difference between the times is 2 hours, or anything to do with that kind of things. Two objects typically, or two times, two speeds, two something to do with travel. And we'll do a couple of puzzles like that. And then we'll finish with the upstream, downstream puzzles, which tend to be a boat paddling upstream, and then another, it turns out, and then it paddles downstream, and you're given some information about that, and your job is to find what the current of the stream is, what the speed of the stream would be, for instance. So that's a big view of what's going on. Let's look at some specifics then. Right, over here I've got some homework-like questions. Let's look at solving a question like that. I'll hide this for a little while, it's a distraction. Right, well, we definitely have some fractions in it, so it counts as a rational equation. Anytime you have fractions, you have that. Very often there's more than one way to solve a question like this. So if the way I'm about to show you doesn't work for you, there are other ways to do it. I'll show you two ways to do this one as an example of that. Right, first thing that strikes me is, do you notice that this fraction and that fraction share a common denominator? You see they both have x plus 2 in the bottom. So that gives me an idea that it might be a good idea to get those two things together. So I'm going to subtract this fraction from both sides. So now I am looking at that. Now, since I have two fractions that share a common denominator, I can combine them to get one fraction equals 2. And then I do a little trick. Why do you think I'm writing 2 as 2 over 1? What's coming next?
So you can cross multiply?
Yeah. So cross multiply. I think someone last time, either at the end or during class, went and said, which one do you do first and which one do you do second? The answer, it doesn't matter, they both work. So for no particular reason, 2 times this guy is equal to 1 times this guy. And that's 2x add 4, and that's x take away 10. Now, the whole goal of the technique called cross multiply is to get rid of fraction equals fraction and turn it into a situation where there are no more fractions. And then when you get to this stage here, don't you do the, as I call it, as long as you do it to both sides, it's okay rule. And in this case, I might subtract an x from both sides. Then I would subtract a 4 from both sides, and I've just solved our first equation. So do you see that's a little bit different from the typical ones that we've seen before, right? It's not a cross multiply, it had to become one. Now, I said that there are two ways to solve this question, so let me show you the second way. I am going to find a term to multiply everybody by. It should be an equals in here. There we go. To multiply everybody to make the fractions go away. And the thing that I'm going to use is x add 2. So I'm going to multiply everybody by x add 2. Okay. If you multiply this fraction by x add 2, you just get x. If you multiply 2 with x plus 2, you get that. And if you multiply 10 over x plus 2 by x plus 2, you get that. Do you see that I've removed the fraction? We don't have fractions anymore. What I'm now going to do is distribute the 2's. Combine the numbers. Subtract 2x from both sides. And then divide both sides by -1. There's our solution. So you see there was two different approaches to solving this particular equation. I think the goal with solving an equation is you just need to find a way of figuring out what the missing value of x is. So you may do it one way and someone else does it another, but as long as it's mathematically correct and you get the right answer, yeah, that's fine. I don't really have an issue with that. So that's our first example. This is a second one. I'm picking questions out of the homework from that last section. Although the numbers will change because that's what the WebAssign does. Right, look at this horrible guy. We are going to use the technique of finding some term that gets rid of all these fractions at once. Right. If I wanted to get rid of 1 over b, wouldn't I just multiply both sides by b? If I wanted to get rid of a half, couldn't I multiply everybody by 2? And if I wanted to get rid of 2b, wouldn't I multiply everybody by 2b? So as long as you do the same thing to all the terms in an equation, it's allowed, right? As long as you do it to both sides, it's okay. So I'm going to multiply everybody by 2b. If you multiply 1 over b with 2b, you get 2. If you multiply a half by 2b, you get b. If you multiply 9 over 2b by 2b, you get 9. Do you see how that horrible equation has now turned into a really nice, pretty simple equation? What would I need to do just to finish this guy off?
Add 9.
Yep, just add 9. And there's your answer. So we're still working on the solve the equation issue, I guess. And this is question 3. 5/7 plus 16 over a plus 6 is equal to 3. Now, one of the things you've got to realize is that you don't do the same technique on every question. Sometimes you have to adapt depending on the circumstances. And what I noticed here is, do you see how there's a fraction here, 5/7, and there's a number here, 3? If you forget that ugly guy in the middle, couldn't I at least get the 5/7 and the 3 together to reduce into a single value? Right, because they're both numbers and fractions. So what I'm going to do is I'm going to subtract 5/7 from both sides. And now it gets a little bit messy. If you want to take a whole number and subtract 5/7 from it, don't you have to convert the whole number into sevenths so that they share a common denominator? So the number 3 is the same thing as 21/7. That's 3. Then I can take away 5/7. And what that leaves me with is 16 over a plus 6 is equal to 16 over 7. Now, if you look at the original question, the original equation, which was this guy, do you notice that this is a lot nicer because of what we're about to do next? Do you see that this is a candidate for cross multiplication? Fraction equals fraction is cross multiplication. So I'm going to go 16 times a plus 6 is equal to 16 times 7. You know, I could have cancelled those 16s, but I'm not going to. That's 96. And that guy there's some ridiculously big number that I'm about to find out what number that is. And if you go 16 times 17, we get 272.
Shouldn't it be 7, not 17?
Yeah, that's where I was confused.
Did you catch that deliberate mistake, everybody?
Yeah, I was confused.
16. This is the start of the night. I haven't even warmed up yet. That's 112. Now, if you take 96 away from both sides, that guy there becomes 16. And then divide both sides by 16, you've got your answer. So it did work out quite nicely, didn't it? The solution, at least. The original question was horrible, totally horrible, but the final solution wasn't. Any questions about those three? Because that's the thing you just have to work on. Because there are so many different flavors of equations, different equations. Next fella. Does that question remind you a lot of the one we just finished a few moments ago? Can you see it's got a fraction over here and the number here? And if you could get these together, wouldn't I have a single fraction? So I'm going to do the same calculation, the same process. I'm going to go a over a take away 5. And I'm going to subtract 3/5 on both sides. How many fifths is the whole number 2 the same as? How many fifths is the whole number 2 the same as?
10.
So 10 take away 3. Are you happy where that 7/5 came from? 10/5 subtract 3/5 leaves you 7/5. Do you see what my goal here was to try and get the cross multiplication situation, right? Fraction equals fraction. Now, cross multiply is going to be the next step. So 7 lots of a take away 5 and 5 times a. 7a take away 35 is 5a. Okay, where are we off to next?
Subtract 7a.
Oh, you know, that is not the way I would do it, but that works, so I'm going to do it. As long as you do it to both sides, it's okay. So if you subtract 7a from both sides, I believe you get that. Okay, one more step in this question is finished. What do you now do to both sides?
Divide by -2.
Right, it's not the prettiest number in the world to divide by. In fact, when I do that, divide by -2, isn't the answer going to, at least superficially for now, isn't it going to look like that? But don't two negatives cancel. So that's what its final answer is going to be. I'd like 5 and 7, but sometimes the answer's just ugly and you live with it. Any questions with that? Do you feel comfortable with that process? Good. Well, that's the end of what I called solving equations. These are very special, weird kind of equations. And some of these, or ones like the ones we've done, are going to appear later on when we solve the word puzzles. But right now, that's the end of them. So now we're going to do number 2, which I've called calculate rates. This probably won't work, but if it does, I'll be really happy. Can you read this?
Barely.
Barely. Okay, there's a little thing called autofocus. I'm going to try it, see if it does anything. Can you read it now? Is it still barely, or is it
It's
worse even?
just visible.
Just visible. Okay, let's try slightly more position. Try that. I guess my technology is not up to it. Do you know what I'm going to just do? I'm just going to read what that says, and you'll trust me. It's actually question 5 from the homework, so if you want to see what question 5 looks like later, you can do it. I was hoping that it would actually, that my little gizmo would be good enough, but evidently it's not perfect. Okay, so in question 5, this is a homework question 5, it takes a security officer 42 minutes to check each of the doors in an office building to make sure that they are locked. Okay, so he goes around the building and somebody's timed them and it takes 42 minutes. You're being asked to find what is called the rate. So what's the officer's rate? Well, you take the job and you divide it by the time. So that means that his rate is he takes 1/42 of a minute per door. Okay. B, it takes a high school mathematics teacher 3 hours to grade some work. What's his rate? When you do rates, the 3 goes in the bottom. And the 1 goes in the top. So 1 job is 3. Now, if he has to do X exams, then the rate would be X over 3. Okay, let me pick my own questions. That way I can write them down. So John takes 50 minutes to mow a lawn. It's X units big. So the rate he takes is X over 50. So just think of rate as something you do divided by 50. Now, if that wasn't called X, if that was just called his lawn, then it would be 1 over 50. And 1 would mean lawn, and 50 would be the time. That is pretty much what a rate does. You know, if you say, well, there's 2 rates. Do you know that the speed of your car is a rate, isn't it? Miles per hour. 40 miles in an hour. So if somebody said John took 80 hours, did 80 miles in 2 hours. Wouldn't his rate be 80, what he did, divided by 2, how long it took him to do it? 80 divided by 2, his rate would be 40 miles an hour, right? If I went and said to you that I took, I don't know what letter, I took Y miles, that's how far I travelled, and it took me 3 hours, then my rate would be Y over 3. Have you noticed that every single rate is a fraction and the bottom is the time it takes you to do it? So your rates are typically going to be some variable that you may or may not know, in this case we don't, over 3. So here is us now on to solving problems with rates. And so you're going to get lots of practice at them. You can't read them, so here we go. Question 7. A homeowner figures out it'll take him 16 days if he does it on his own to roof his house. So the homeowner will call X the house, and it takes him 16 days. So X over 16 is his rate, right? 16 days to do the house. I don't know how big the house is, so I'm calling it X, so X over 16. Now, it then goes on and says a professional roofer could do it in 3 days. So the professional has a rate. Well, he does the same thing, but he does it in 3. Now, the kind of questions that you're going to be solving here are rate puzzles, rate word puzzles. And here's the question that they ask. How long would it take if they both work together to roof his house? So whenever you get a question involving somebody taking so long to do this, yeah, the next question might be, Peter takes 2 hours to mow the lawn. His brother James, it would take him 3 hours to mow that same lawn. How long would it take them if they work together? They have that kind of feel to them, right? So they're going to be 2 people, 2 things. Each one has a different rate to do the same job, and then they work together. And the puzzle is, how long would it take them if they work together? Now, when you see that, and this is the generic way that you solve the equation, I'm just going to call them rate 1 plus rate 2 equals the whole thing, and the whole thing means 1. So if you ever have one of these rate questions, I think there's 3 or 4 in the homework, you find the rate of the first person, that's a homeowner. You find the rate of the second person, that's a professional. And when you add these together, you get 1. And what you end up getting are equations that look like this. So now we have to worry or think about that doesn't look right, but I don't think I can spell. Doesn't professional look kind of weird? Hey, it's how we spell it in Scotland, right? Didn't say English was my strongest suit. So I'm going to rewrite the question up here because I need some room. You can see it's a rational equation. It's got a 16 in the bottom, it's got a 3 in the bottom. We are going to use this technique. Multiply both sides by a certain number. Now, if I multiplied everybody by 16, wouldn't that become X? And that would become 16. but it wouldn't help x over 3. Would you agree? X over 3 times the number 16 doesn't help. On the other hand, if I multiplied x over 3 with 3, wouldn't that get rid of the over 3? Right? But it wouldn't help with that one. So who is this magic number? The number that you use is 48. Whatever these two multiplied together, that's the magic number. And as long as you do it to both sides, it's okay rule. So here goes. If you take x over 16 and you multiply it by 48, and then you take x over 3 and you multiply it by 48, and then you take 1 and you multiply it by 48, that is allowed, right? I'm doing the same thing to all three guys. Well, let's see what the cool thing is. Why 48 is such a good number? Would you agree that they cancel? Can I count? 16. What's that, 3? Yes, it's 3 times. Suppose I do this one. Oh, 16 times. And this guy, 48. So 3 times x gets you 3x. 16 times x gets you 16x. And it's equal to 48. Do you see what I've done here is get rid of all the fractions? And I've done it by a really clever trick of finding a number that makes everybody disappear as far as fractions are concerned. Now at this stage here, you can add the x's together and then you can divide both sides by 19. And you would expect to get nice answers, but what I found is that you tend to get really ugly answers, but it's still right. Would you agree that's not a very nice answer, but it's right. So the only thing you need to worry about is at the end, is that if you get something that's an ugly fraction like that, if you can, you should simplify it. And this one doesn't simplify, so I'm finished. But this one I could. Couldn't I divide top and bottom by 3? And that's the answer that you should use, if that happened. So in a rate question, we're going to have 2 rates. We're going to add them together. They're going to equal 1. That's going to generate a question that has 2 fractions equals 1. And then we solve it by this multiplication technique that I just showed you. Okay. This is question 8. A conveyor belt takes 11 minutes to empty whatever it is. So I'll call that the new machine. And the new machine's rate is it takes 11 minutes. So I think it's empty the thing. So that's x over 11. And they've got an older machine, or whatever you want to call it, the other machine. And the other machine has a rate, and it takes 18 minutes to do it. So can you imagine you've got a big grain mill and this thing's emptying, and one of them takes 11 minutes to do the job and the other takes 18 minutes. Do you see how it's always x over a number, x over a number? Now, the equation that that's going to generate is that. I bring my other guy, if I can find him. You notice that this question had a very similar look, isn't it? The 2 rates added equals 1. Now we are about 3 lines off finishing this puzzle. The way we're going to tackle this question here is we're going to find a number that we multiply all of them by that makes every single one of these fractions disappear. What would the 2 numbers be, or at least how would you find the number that would do that?
11 times 18.
Yeah. Now don't worry about the fact that's some ridiculously huge number.
198.
Oh, you're ahead of the game. It's 198. Now, if you take each one of these guys and you multiply them by 198, the fraction is guaranteed to disappear. In fact, something else always happens. Do you know how this number has an 11 here on the bottom? When you do this, it becomes 18x. And do you see how this has got an 18 in the bottom? When you do the multiplication, you end up getting 11x. Do you notice that they two numbers appear in the answer? They kind of swap places. You see how this guy gets the 18 and the other guy gets the 11? That's not coincidence. You'll see it happens every time. So that's going to get me 29x equals 198. So that's going to get me 198 over 29. And I don't think you can simplify that, so I'm finished. Okay, I'm going to give you a story like that and see if we can do it, right? So I'm just making one up. We'll do somebody doing their garden, cutting the grass. So that's going to be my puzzle. Right. So we'll have John. He takes 4 hours to cut all the grass, right? To cut the grass at his home. His brother Peter, well, he's not as good. He takes 6 hours to cut the grass. How long will it take to cut the grass if they work together? Okay, we'll give you, it's hard to judge how long this is going to take. I'll give you 3 minutes. Not a long time, but if you know what you're doing, it probably should take 3 minutes. I think, judging by at least the visuals, that you've finished. Right, so let's do it one at a time. Right, John takes 4 hours to cut the grass. How do we describe the rate at which he's doing it? So what will I write down for John's rate?
Over 4.
Would you agree that Peter is x over 6 then? For these kinds of stories, is it reasonably easy just to read the question and to realise how to get the rates, right? It's x over how long it takes them to do. X is basically just a placeholder for the job. Now, when they work together, you get that. If you're wondering what the 1 represents, the 1 represents the whole job is done, right? There's one job to do and they've done it, right? So that's the 1 is always there, right? Now, what's the magic number that's going to work for this?
24.
Okay. Have you noticed what I said, that this becomes 6 and this becomes 4 and this becomes 24? If you recognize that, doesn't that question just become a little bit quicker because you don't really do multiplication because you know what the pattern is? So in this case, what am we going to get? 10x is going to equal 24. Right, divide everybody by 10. Can I simplify 24 tenths?
At 12 over 5.
Okay. And that's fine, that's all we need. You don't need to turn that into 2.4, whatever it is, it's good. So if you get a question about 2 people or 2 things doing something, and one has a different rate than the other, and then they ask you how long will it take if they work together, that's what I mean by a rate word puzzle, right? Like the ones we've done here. Do you feel comfortable with the way the story looks and how you would go about getting the answer to it? Do you want me, can I call that done then and we can move on? Okay, it's done and we will move on. So, that's not a piece of paper. It is this one. This one's from question 10. There are only 2 more groups of questions to do, and that's everything that you need to know for the midterm. That's all the different flavors of word puzzles that involve fractions. So that's a good thing, right? Only 2 to go. Right, here we are. This is journey questions. So these are journey puzzles. These are going to be stories involving things traveling, trains, buses, and so on. So in this particular one, 2 trains make the same 480-mile run. So I'm going to, because I'm a visual person, I'm going to just draw a wee picture to help me see what's going on. So going from there to there, it's 480-mile run. Okay, I got that. Since one train travels 10 miles faster than the other, it arrives 4 hours earlier. So I'll write that down in English. One train travels 10 miles per hour faster than the other. And because of that, it arrives 4 hours earlier. And we're being asked to find the speed of both trains. So it's a journey. In this case, it's 2 trains. And we know a little bit about the journey. We know its distance is 480 miles. And we know a connection between the 2 trains. One of them goes 10 miles an hour faster than the other. We also know that the fast train arrives 4 hours quicker, right? It takes 4 hours less time to do the journey than the other, right? And we're being asked to find the speed of both trains. So I'm going to start with that. I'm going to call the trains the fast train. And I'm going to do the other one, I'm going to call the slow train. That would make sense. You've got to label them some way so you can keep track of what they are, right? There's 2 trains, right? Fast train, slow train. As good a name as any. Now, I do not know the speed of any of these trains. So that means I'm going to put an X there to represent the unknown value. Now, what I do know is that the fast train goes 10 miles an hour faster than the slow one. So if I call this guy X, can't I call the fast train 10 plus X? Do you see what I've managed to do there is use this piece of information to help me algebraically. So far, so good? Now, the next piece of information involves the time that it takes. So I'm now going to find the time it takes for the fast train. Well, you have to know a little formula, which I hope you do remember. If you want to get the time that a journey takes, don't you take the distance and divide it by its speed? Can you remember that? Time is distance divided by speed, right? So if you wanted to go 100 miles and your speed was 50 miles an hour, wouldn't you do 100 miles distance, right, divided by speed 50? So what do we have here? Well, for the fast train, it's going 480 miles and its speed is x odd 10. And the time for the slow train, well, it's still doing 480, but its speed is x. So what I've got here is a connection between the two times of the trains using the x's. And the whole goal here is to find the x. Now, this is the guy that's going to be the killer. This is the guy that's going to make it all work. It arrives 4 hours earlier, right? Now, there are a number of different ways of saying that, but wouldn't the time, this is one way of doing it, the time that the fast train takes take away, subtract the time that the slow train takes equals 4. Wouldn't that be one way of saying that? And I've just made a boo-boo, but I can fix it. What's the boo-boo I did? It's almost right, except for one major difference. The difference is 4. But shouldn't it be that? Doesn't the slow train take a big number of time and the fast train take a small number of time? So shouldn't it be big take away small? That's what I was doing. Right. That means I have 480 over x take away 480 over x odd 10 equals 4. Now, if this was an exam question, and if you get a question like this in the exam, you'll only get one, so you won't have 4 to do, you'll only get one. If that happened, if you'd got to this line, you've got half the points, because that's, in itself, that's quite a lot to do. So now we need to focus on algebraically how to solve this equation. You don't need to do this, but I do. I need more room. So I'm going to move it over just a touch. God, that's an ugly looking equation, isn't it? That is one ugly equation. See if this thing was x over 3 and x over 4, wouldn't I just multiply by 12? Remember the trick that we did? You find the two guys and you multiply them. I'm going to use that same trick. It's just going to look weird. If one of the numbers in the bottom is 4 and the other number is 3, can't you just multiply by 12? When one of the numbers is x and the other is x plus 10, I am going to multiply everybody by x odd 10. Essentially, it's like 4 times 3, isn't it? But we're using variables. Now, if you take this ugly fraction, 480 over x, and you multiply it by that fella, and if you take the second fraction, which is this fella, and you multiply it by that, and I didn't give myself enough room there. If you do this guy, you get that. Okay. What's going to happen when you take this fraction and multiply it by this guy? Don't the x's cancel out and you're left with 480 x plus 10s? Take away. If you multiply these together, the x had 10s disappear and you get take away 480x. And now you look at this horrible guy, you got 4x times x, which is 4x squared, and 4x times 10, which is 40x. Now I'm going to distribute 480x plus 4,800, take away 480x, equals 4x squared plus 40x. I guess the only saving grace is there's only 3 of these questions. That is one horrible looking equation. No argument about it. But we have to keep working. Do you see anything on the left-hand side that might work in our favour?
480x.
Okay, don't they essentially kill each other off? I'll take what I can get. So that's 4,800 is equal to 4x squared plus 40x. What could I do to both sides next? It's kind of messy, isn't it? Suppose I subtract the number from both sides. So far, so good. Okay. Do you recognize this as a trinomial? I'm going to do something here to try and reduce it. If I tried to factor that, I'd be here to Christmas. There are so many combinations there, I don't know how long it would take me, but it would take me far too long. So, did you notice that all these numbers at least can be divided by 4? So, if I divide everybody by 4, now don't be scared by the size of this number. I need 2 numbers that multiply together that give me negative 1200, and when I add them, I get 10. So because it's a negative number, doesn't that mean 1x and 1 minus? And don't go looking for weird 38s times 47s. Think nice and round. Because if nothing, they at least have to help you with the numbers, right? They have to at least make the numbers nice to deal with. There is a combination of 1200 that differs by 10, isn't there? Anybody want to tell me what it is?
Plus 40 minus 30.
That's what I'm getting at. See, it's nice numbers, right? It's not 25 times 78 or some weird combination that you'd be here all day doing. If it was one of them, that question really wouldn't be fair. Can you imagine that there are many, many combinations of 1200s, right? But the fact that that was a 10 was a clue that it was going to be nice round numbers. Well, we're almost dealing with this. Do you know that the solutions are x equals 30 and x equals negative 40? Which one of those two am I throwing out because it's silly?
Negative 40.
So the answer to this puzzle is x equals 30, right? You can't get a speed of negative 40. X represents speeds here, right? So negative 40 would be going backwards, I guess. I mean, we're not going to do that. So we got 30. So we are now going to go back to the original question, which is, what are the speeds of the train? Well, The slow train is going to be 30, and the fast train is 10 more than that, and that's 40. And that was a lot of work for one question. But it's done. Are we going? I'm going to do one more of these guys. They take a long time, as you can imagine. That will be the end of those stories. So hopefully when you see two of them together, you'll see that they do have a kind of shared pattern, but they're only 3 questions altogether, so there's not a lot going on. This one is question 12. And it is, a trucker drove 120 miles to make a delivery. So that's 120 miles. And if I read on a little bit further, when he come back, it was foggy. So he went at 20 miles an hour less. So we're going to have the fast speed, and we're going to have the slow speed. Well, if I call this X, on the way back, he had to go slower, and he had to go because of the fog. In the story here, what did they say? The fog, he had to do it 20 miles an hour less. So make one of them X and make the other X plus 20 or X minus 20, depending on the story. As I read a bit further, the return trip took 3 hours longer. Okay. So I'm now going to find what the time for the fast one is. I'm going to find the time for the slow one. And in this case, it's 120 over X. And 120 over X take away 20. And then I'm going to say, okay, the time that it takes you to do the slow one minus the time it took you to go on the fast one. That number there, take away this one here. And in this story, the difference was 3 hours. Now, if you did fast train, slow train, doesn't have very much the same look to it. Speedy one of them, speedy the other. In this case, it's a minus, but apart from that, it's the same, right? Would you agree you calculate the times of each? Distance divided by speed, distance divided by speed. And then you notice that the difference between them, which means subtraction, was 3 hours. So now we have to do the horrible bit again. What weird thing am I going to multiply all of these by so that the fractions disappear?
X minus 120.
Is it just X minus 120 or X minus 120 and somebody else? There is a somebody else.
X minus 120.
Right. Do you notice that all you do is pick these two guys, whoever they are, no matter how ugly they are, no matter what they even look like, just pick them and you'll be fine. Now, can I speed things up? If you take this fraction and multiply it by this, don't you just get the X left over? Right? So if you take this fraction and multiply it by this, don't the X 120s kill each other and you get 120X? If you do that same shortcut, what will happen with this fraction when you multiply it by that? Won't the X's cancel out? And you'll get what, an X minus 120. And then 3, I'll write that down. So I have 120X, take away 120X, plus 1400. And that's going to be 3x squared, take away 360x. Now they cancel it, and I have that number, 3x squared, take away 360x. Subtract 1400 from both sides.
Shouldn't it be 14,400?
If I missed a zero, this fella here should have an extra 4. Yeah. 12 12s is 144 and add 2 zeros. Yeah, so that's what it should be. Oh, darn it, in space. This is not a nice calculation, is it? I didn't swear because I know what I'm going to do next. It might not be much, but it'll be better than nothing. Can I divide both sides by a number just to make things a little bit prettier? What number can I divide everybody by?
3.
Yeah. So that'll get me an x squared. That will get me 120x and, whoa, 144,000 divided by 3 gets me 4800. Two numbers multiplied together give you 4,800, but the difference between them is 120. So I'm assuming that those two guys are pretty close to each other. Right. Any suggestions? I'm checking myself. I got it. Anybody else got it? Or do I have it? Ooh, no, I don't. I don't have it. I thought I had it. I was going to do 30 and 160, but that doesn't work. I'm just going through all the nice ones, right? 20 and some, 30 and some, 40 and some, things like that. I haven't got anybody that works, which is worrying.
Why did you switch the x minus 120, or is it supposed to be x minus 20, not x minus?
Bugger it in space. That's what I did wrong. That's why it didn't work. Yeah. You see up here, for some reason that I cannot explain, I wrote down 120, which is why I couldn't get this to work. I am not going to let that. I'm not going to let that disturb me. You are now about to get a very quick version of that same question, just so we can get to the numbers and finish this. We're still going to multiply by x, but it's going to be x take away 20 now. So that's going to be 120 x take away 20. It's going to be 120x, and it's going to be 3 times x, x take away 20. So basically all those 120s should have been 20. Now this gets me 120x take away 2400 plus help me out here. It's a takeaway. Finally, I caught it in time. So I can't go things quickly. There we go. It's takeaway that's 3. So that's a takeaway, that's a takeaway. So these two cancel out, and this is negative 2400. It's 3x squared, and it's takeaway 60x. If I add that number to both sides, I get that. If I divide everybody by 3, and now I can think about what the heck's going on here. 40 and 20, there should be a minus in here. There should be a minus in here. I know the answer is 40 and 20. Why am I not getting the right sign? Why on earth am I not getting it?
Did you switch
Hi.
the positions of?
I-
You put the fast train first instead of second.
Oh, I got them back to front. Okay, I'm not doing this again. I will take a few minutes, probably tomorrow. I will do that question really carefully and I'll stick it up as a PDF. First time I did 120 when I should have done 20. And second time I got them back to front. And I'm not going to do it a third time because do you know what's going to happen if I did it a third time? I would do a third mistake because I'll be so busy thinking about the two other mistakes and so on and so forth. So I'm just going to put that one up to experience and I'm going to have to take a little note to myself. So I'll put it here. Number 12. Do the work. Okay, and I'll stick that somewhere easy to find. Well, it shouldn't have been anywhere near as hard because it's already hard, but it shouldn't have been as hard as I made it out to be. If the question is written down correctly and you put it in the right order, it does eventually work, right? You just trust me on it, it does eventually work. We've only got one more puzzle question to do, and that's really it. So we're going to do the upstream, downstream question. Now, on the ones I've got here, that's going to be questions 13, 14, and 15 on your homework. So there are 3 of these in your homework to do. The first question, I'm going to write it down. It takes 8 hours for a boat to travel 18 miles upstream. If the return journey make sure I don't read one from 2 different questions. Right, I did. That's me and my scanning. That's right. Now, it then goes on and says, if the speed of the boat in someone just came in, speed of the boat in still water is 6 miles per hour, what is the current? And I am going to double check that that isn't a combination of 2 different questions. It takes 8 hours for a boat to travel 18 miles. Upstream. Gotcha. If the speed of the boat in still water is 6 miles per hour, what is the speed of the current? Okay, let's visualize it. Here is a river. Let's have that as the current. And let's have its speed as X miles per hour. So can you imagine the current might be 10 miles an hour, it might be 2 miles an hour, right? And our job is to find that missing speed of the current. So what is the current speed? Now, what do I know about this? Well, It takes 8 hours for the boat to travel 18 miles upstream, and I also know that the speed of the boat in still water is 6 miles an hour. So I'm going to find the speed of the boat upstream. And I'm also going to find the speed of the boat when you go downstream. If there was no current going at all, right, if it was just a still river, you'd go 6. But there's a current. When you're going this direction here, that's called upstream, right? You're going against the current. So I guess if you've ever canoed upstream, don't you go slower because the current's kind of fighting against you, right? Or if you're on a ship and you're using the current of the sea, you might get a bit of an edge. And when you go in this direction here, would you grade's downstream? So I'm just making sure that the terminology of upstream and downstream is clear to us. So let's see what the speed is. If there was no current, I'm going 6. But there is a current. Now, isn't that current working against me? So my speed will be 6 take away x. You agree? 6 take away x. Now, what happens when I turn the boat round, right? I get to here and I start going this way. Won't my speed be 6 add x? Because not only am I going downstream, isn't the current giving me an extra little shove and I'll go faster? So using the information that we've got so far, I now know what the speed of the upstream and the downstream is. Very good. Now, what else have I got here? It takes 8 hours for the boat to travel 18 miles upstream. Now, if you want to take the time, how long something takes, isn't it the distance divided by the speed? And you're telling me that 18 miles is the distance, right? And we know what the speed is. Isn't the speed going upstream 6 take away x? And do we know how long that journey takes? Yes, we do. Do you see I've got my equation? 8 hours to go upstream. 8 hours to go a distance of 18 at a speed of 6 minus x. I've just noticed in this particular question, didn't the speed of the boat going downstream not have any effect? It wasn't actually even necessary to calculate it in this question. Now, if I want to solve this question, it's a lot nicer than the 2 that we tried to do earlier, or I tried to do earlier. If I call it this way, can you see where this is going? A little cross multiply. So 8, 6 take away x, and 1 times 18 is 18. 48 take away 8x is 18. Are you much happier with the equation that this one generated compared to the really, really ugly one the journey ones did? Okay, we are about 2 lines off finishing this. What should I do to both sides next?
Divide everything by 8.
Not yet,
Right
that's
now.
happening, but that'll happen later. But right now there's something else to do before that.
Minus 48 from both sides.
Yeah, you have to get the x's on their own before you do that, right? And now you can do the division, right? So we're going to divide both sides by minus 8, which is positive, that guy. What can I do? 2. There you go. X is the speed of the current, isn't it? X is 15 over 4. We're finished. Not as bad as the other one? Okay. let's try. As I said, there's what, 3 of these fellas? So that was 13. Let's do 15. That way you've got a shot at doing some yourself as well. A helicopter spraying fertilizer over a field can fly 0.6 miles downwind, just like downstream. And in the same time, he can fly 0.4 miles upwind. Right. Find the speed of the wind if the helicopter travels at 45 miles an hour when there is no wind. Okay, so I'll do my little picture. The distance between here and here is 0.6 miles. Let's have the wind being that arrow. And we'll call it X because we don't know what it is. It's very similar to the water current, isn't it? Although it's wind, it's pretty much the same story. And what do we know? Well, here's my well, it's not an aircraft, but I can't draw helicopters. So there it is. That's my little guy. And if the wind isn't blowing, that's 45 miles per hour. So let's find the speed of the helicopter. The speed of the helicopter when you're going upwind, and the speed of the helicopter when you're going downwind. If you're fighting against the wind, that's upwind, won't your speed be 45, take away whatever the wind is doing? And then if you're coming back the way, isn't the wind actually helping you and pushing a little bit? And so that's 45 add X. So we've got those two speeds done. Then I'll read a little bit more of the story. It says here the helicopter spraying a field of 0.6 downward, the same as he can do upwind. So let's find out what the times are. The time when you go upwind. Well, it's a distance divided by your speed. And when he's going in that direction, he can only do 0.4 of a mile, and his speed is that guy. So that's the time going upwind. And the time he takes coming downward, well, that's going to be the distance, but that's a lot better. He can do 0.6, and he's going to have a speed of that guy. And we now have 2 equations that talk about the time that journey takes. In this story, they tell you that the time for that journey is the same as the time of that, which is really good because that means that this fella is equal to that fella. This time is the same as that time. The story says the time it took him to go 0.6 that one way was the same as 0.4 the other way. Do you see that if the times are equal, it means these are equal? So it's a different piece of information, but it was useful. In fact, looking at that, do you see a cross multiply? Pretty messy one, but I'll have to do it. 0.6, 45, take away X. 0.4, 45, add X. 0.6 times 45 is 27. Take away 0.6x. 0.4 times 45 is 18. Add 0.4x. Okay, we just need to solve this equation for x, and this is the end of the question, and we are done. As long as you do it to both sides, it's okay, roll. Tell me what to do to both sides to get closer to the final answer.
Take 27 away from both sides.
Sounds like a plan to me. Just trust the math. This is going to come out okay. It might look a bit scary right now, but it's going to come out really okay. Okay, what am I going to do to both sides next? Remember, if you don't hit the space bar, I can't hear you.
Take 0.6 away from both sides.
Okay, so, oh, you're going to take 0.6 away from both sides? Is that what you said?
Yeah, sorry.
0.4.
Okay. But, well, I never make mistakes, so I'm really surprised. I'm really surprised. Basically, I should have called that 1x, but I got kind of careless, right? Okay, it looks weird, but don't you just divide both sides by -1? And hey presto, the wind is 9 miles an hour. Is your dog wanting attention? Yeah. What's his name again?
This one's Nala.
Nala? That's a cool name. Is that a girl?
Yeah.
What's the other one's name?
I have 3 other ones. I have
Wow, you
Luna,
got okay.
Kaya, and Takani.
Do they have a native connection or an Asian connection? I mean, they sound foreign in some way to me.
Takani's a little bit native.
Okay. And what breed are they?
Siberian Huskies.
Oh. Do they require a lot of exercise?
Mine are actually pretty lazy.
That's probably a good thing when you're a student. Okay.
Yes.
Okay, we are finished this question. We are finished the puzzles. We are finished everything that you need to know for the midterm. So I'm going to now go and show you, and we're going to talk a lot about, or as much as you want me to talk about, the midterm. So if you give me a few seconds to load up what I need to load up, we are good. I think it's this one. Nope, that's me getting my lectures. Let's try another one. No, okay, I'm having whatever you want to call it, technical difficulties here. Right, I see it. There, you little darling, it was hiding. It's all these weird windows. No, that is not good. Let me click on that one, see if that does any good. Something really weird is happening here. Ah, that'll do. Okay, and if I hit this one, good. Are you looking at Canvas now? Yay. Now, I'm going to kind of start at the end and then work my way forward. So on Tuesday at 5 o'clock, WebAssign is going to have your midterm exam open. The questions from that midterm exam are generated by WebAssign. So there shouldn't be any weird ways that they phrase it. They will look very similar to homework questions because they're taken essentially from the same big bank of questions. And you're going to do those questions, and you are going to finish by 8. So it's 5 till 8. That's 3-hour window. And it's going to be on everything that we've done since the start of the quarter, right? So all that cool stuff that we've done. And when you're finished, you're going to upload it using this fella here. So if I wind back a little bit, you're going to have your working, and I need to see it for a couple of reasons. I'll come into that later. And you're going to take pictures with your phone, and you're going to use this piece of software here called Adobe Scan. So if you click on this little link here, if you've got an Android phone, you'll click on this and you'll get the software. And if you've got an Apple phone, you click on this. And I believe it's free. It is for me anyway, so it should be for you. And you take pictures of all your homework, maybe it's not your homework, all your working, maybe it's 7 pages. You take 7 pages, 7 pictures. It turns it into a PDF, a single PDF, and that's the thing that I need to see. So that PDF that you've now got, you're going to get it to me, and let's show you how, if I can. Okay. Now, I'm going to go on to Student View. And when you click on this link, you see that big Submit Assignment? Top right hand corner, Submit Assignment. You're going to hit that. See that thing there called Choose File? You're going to hit that. And you are then going to go to wherever you happen to have your files stored. Me personally, if I was doing it, see after you take all your pictures of your homework and you've got a PDF, I would send that to yourself as an email attachment. And then go to your email and just download it onto your desktop, right? Somewhere easy to find. Let's say it's that guy there. You click on it, you say open. You see it's there now. Now, it's quite clever. When you go into Canvas, anything you upload only goes into your Canvas shell. So when I go looking, I know this one is yours and not someone else's. Now, once you've done that and you're happy, you hit Submit Assignment and you're finished. That's your midterm over. You've done the work, you've done the working, and you've submitted it. So let's look at some problems that could happen. Can you imagine that you submitted it and you suddenly realize that you missed a page, right? You did all the working, but there was one other that you kind of forgot somehow to do. Then all you do is start again from scratch, do all 7 pages or all 8 pages, save them again as a different PDF, and go back here, right? And see how it says Submit Assignment? You click on it, you choose the file, you choose the new one, you hit Open, and you submit it. And it will rub out all the old versions, and the only thing, you see here, I could resubmit it again if I made a mistake a third time. It will only keep the last thing that you uploaded. So don't upload the 1 page that you missed, because if you do that, it'll rub out the 7 pages you did, and all I get to see is the last page. You have to redo it as an entire, you know, big chunk, everything in one place, and upload that. And that will be your, that will be you over. So that's kind of what would happen at the end. Let's see. I'll leave Student View. Are we back to Canvas? Right? Okay, so everything that you're going to do in the midterm will be similar to what you've done in some of your homeworks. There shouldn't be any, oh, we've never done that, or I've never seen a question phrased in quite that way. It should be hopefully standard. The midterm's designed to last 2.5 hours. So the fact you're getting 3 hours gives you an extra half hour to work with. So that's good. I need to see your working. If I don't see the working, I'm going to be quite strict about this. So I'm telling you up front, so you can't say, oh, I didn't know. If you do a question and there isn't any working attached to it, I'm not going to give you any points. Now you might say, well, I did it in my head. Fair enough. Do it in your head and then write the working down anyway. I have to see it. Right. Now, there are some exceptions to that. Do you know some of the questions, there's a picture or something, or you just click a box because what does this thing mean? You know, those kind of questions. I don't expect working for them, right? That's kind of obvious, right? But pretty much anything that you have to do, like we did today, would you agree everything we did today pretty much had an equation and 6, 7, 10 lines attached to it. So that's what I mean by working. Now, the first reason just is to stop cheating, right? Because you could basically just get the answer, I guess, from somewhere and write down, you know, 42, and that would be it. But the second reason is to help you. You know, the WebAssign is not very good at being versatile. So do you know if you do the correct answer, but you just screw up in one little spot, right? One little line out of 10 lines of working, kind of like I did today, right? It'll give you 0 points because that's the way it works. But I get to see your working and I give you partial credit. So if it's 90% right, instead of 0 out of 20, you get 18 out of 20. And that'll be a big bonus. Do you know if you go to WebAssign, it tells you what your homework grade is? Doesn't it tell you got 90% or something? Have you noticed it does that? Right, so you already know what your homework grade is. So that should help you feel a little bit better. Hopefully it's a good number, right? It's a good grade. It'll tell you your final exam, your midterm exam number. Unless it's a good number, will you not look at it? Because from my experience, you'll get 50 and you'll think, oh God, I've bombed that exam, I'm not going to pass, and you'll have a whole stressful 2 days until you find out that it was okay. Because when I go back to it, it's not uncommon for somebody who gets 50, by the time I look at the working, it's 80 or 85. Right? It's quite a reasonable score. And it's not because I'm being generous, I'm actually trying to be fair here. But you know, in WebAssign, one screw up, 0 points. Right? And it wasn't that you didn't do the question, right? 8 lines of working and 1 line, a +2 turned into a -2, you know, whatever it is, boom. So you're going to get a lot of points by showing me you're working, right? So it's not just me stopping you cheating, I'm helping you. So I'm pushing this as hard as I can. You got to show me working for anything that obviously needs it, right? So what are you allowed to do for the midterm? You are allowed to do a cheat sheet. So if you want to write down any equations or any formula or anything that you've came across that you think might be helpful, certainly you should do that. You can watch any video you like. You can look at any PDF that you like, as long as it's visual or printed in any way, including your own notes, including my notes, that's fine. You are not allowed to talk to anyone about it. You're not allowed to go on tutoring and ask them to do a question for you. You're not allowed to go on blogs and say, how do you solve this? And somebody in Canvas tells you, right? All of those, as far as I'm concerned, are communicating with someone else. So don't do it, right? It's not fair to the people who stick to the game. So we want that to be totally fair. But everything is on. I could put one little caveat on that. You do only have 3 hours. So if you have to watch a 20-minute video to find out how to do one question, do you see you're going to run out of time before you run out of videos to watch? So you should only keep like long things like that, right? Until you're really, really stuck. If I haven't mentioned it before, I will now. A good strategy for the test is to do all the easy ones, the ones you know how to do first. And then the harder ones, you can do them later. Because if you know there's only half an hour left and there's only 2 questions to go, couldn't you spend some time looking up a video or looking over some PDFs or looking over whatever it is, and you don't worry about it because you know you're almost finished anyway? Don't do that in the middle, because then you might not get finished in time, and that's a bad idea. Other things to save you a lot of grief. On Tuesday at 5 o'clock, there will be a Zoom meeting, not like this. You're all expected to be here in Zoom. That way I can talk to you if there's an issue, and you can talk back to me if you get one. Can you imagine one of the questions doesn't make sense? I mean, occasionally doesn't even WebAssign screw up with the numbers and they don't work. Then you can talk to me. Yes, what you got for me? McKenna?
I was actually wondering how many questions were on the midterm.
I haven't made the darn thing yet. I wish I had. If you want me to give you a guess off the top of my head, it's a very rough guess. There'll probably be somewhere between 15 and 20 questions.
Okay, cool.
Right. Some questions will be really quite quick. You know, some questions are, what's this mean? You know, what's the missing word? You do it in 30 seconds. Most of them won't be like that, but there'll be a couple like that. And then at the other end, I think what we did today is a good example. Weren't some of those questions 15-minute questions? So, you know, some questions are really long and some questions are very trivial. WebAssign tells me how long a typical student took at doing that question, right? Because it's got a big question bank in it, knows how long on average, how long everybody took. So that's what I will do. So turn up to Zoom, ask me a question if you want.